First, we inject the chemicals in the reactor. The hydrogen peroxide and ferric chloride into the reactor. And then the hydrogen peroxide will decompose into oxygen acid, filling up the reactor to pressurize the vessel. Until it reaches the determined pressure, the gas will be released to make it flow through the hose, passing through the regulator, to stabilize the flow, and then entering the water tank. Obviously, the water will then push out all the way to the nozzle, putting enough force to generate the turbine, which is connected to the wheel by 2 gears and a belt. Spontaneously, right after the water sprayed out, to rotate the turbine, the gears, and of course, the wheels. The car will run until finally the car will stop as the pressure is insufficient to rotate the turbine. Well, that was just the overall system. Let's focus on the power source. Please.
Okay, thank you, Austin. The next is about the power source. Spectronic 16 is pressurized car that powered by the composition of hydrogen peroxide and ferric chloride as catalyst and produce water and oxygen. In operation, we use about 10% concentration of hydrogen peroxide, and from this stoichiometric reaction, we know that every mole of hydrogen peroxide can produce a half mole of oxygen. So we can calculate the amount of pressure that achieved in a reactor to run the car. And then the next is about the stopping mechanism. Spectronic 16 can stop in certain distance based on the volume of hydrogen peroxide. When the hydrogen peroxide volume in the reactor is fully decomposed, the oxygen pressure will decrease. And then the water doesn't have enough momentum to rotate the turbine, so the car will stop. As you can see here, is the relation graph shows the relation between hydrogen volume and travel distance. And what about the unique feature? Aris, time is yours.
Okay, now we get into the unique feature. We have 4 things that makes our car truly different with the other Camry car. First thing is turbine and height Q ratio. 16-bladed turbine is made from light material combined with 16 to 60 Q ratio to give high efficiency in converting powerful water stream into car movement. Okay, second thing is nozzle. By using 1.2 mm nozzle in diameter, it will give faster stream based on Bernoulli's equation. Faster stream means higher momentum along with high accuracy. This nozzle is also become the key for high efficiency of our car. Next thing is powerful water stream. Instead of using air to rotating the turbine, we're using water to rotate it because water will give higher momentum than given by air. Last thing is low operational pressure. Our car able to move in low operational pressure. So the impact of it, our car has more safety and only need less chemical use. Talk about safety, we're also talking about economical and environmental aspect. Mahen, it's your turn.
Okay, thank you, Aris. Now, I'm going to tell you that our car is safe to operate and eco-friendly. Spectronic 16 only requires 2 chemicals in small amount to run the car, which is 10% of hydrogen peroxide and 5% of ferric chloride. The chemicals that we use are not hazardous, so it's safe to use, and ferric chloride can be used more than once because it doesn't react with hydrogen peroxide, but it just catalyst. And the product of reaction also eco-friendly because it just produces oxygen and water. Below the reactor and water vessel, we have second containment to prevent spill, and we have safety valve that works at 8 bar, twice the operational pressure of the car to prevent overpressure. And we have insulation on reactor since the reaction is exothermic. In making this car, we minimize the cost without neglecting our safety aspect. For car construction, we spend 1,260,000 rupiah, mostly for reactor and water vessel. And to operate the car, we just need 303 rupiah per 25 meters. Why so cheap? Because the chemicals that we use in small amount in low concentration. So judges, By overall, our car is safe, eco-friendly, and cheaper than others.
So that's all the presentation of Spectronic 16, a very unique turbine car that inexpensive to operate and also efficient in chemical consumption. Thank you very much for your attention. Is there any question?
Let me see the time. What time do you have?
Yeah.
Plus one.
They have one extra minute. I'm going to ask you a lot of questions. Let me start with a simple one. This is the 16th edition of Spectronic.
Yes.
Yes. Spectronics, right?
Yep.
Yes. 16th edition, and you have the 15th edition last year.
Yes.
Here or in the Australia?
No. So we each year we produce 2 cars.
Okay.
So this is 16 and 15. So last year is 13 and 14.
All right. So this is this year car. So you
Exactly.
have another one after this.
Yes.
All right. All right. So just to want to make comparison between the 16, 15 is not coming yet, right? It's
Yeah.
after this,
Yeah.
and 13 and 14. Right. Last year you have 13 and 14,
Mhm.
and this one you have this one the 16. So what's basically the difference, the significant difference in terms of design and also innovation that you have done for the 16th version?
Okay. Thank you very much for the question. Actually, this is the first time we are making a water turbine car.
How about previous one?
The previous one is pneumatic car, so it is only using air to move the pneumatic cylinder, and 14 is using electrochemical cell.
All right.
So this is what we changed. We don't want to just use pressurized air, but also pressurized water.
So the innovation here, you use the water, the pressurized water to move the turbine.
Exactly.
So last year is only the oxygen.
Oxygen to move the pneumatic cylinder.
All right. So that is basically the significant design. All right. How about the performance? If you compare this performance with the 13 and 14.
Okay. For comparison, so we compare with another pressure car.
Okay,
Better
yeah.
pressure car. Okay. So in our pneumatic car, the 16th generation, for to reach the maybe around 30 meter, it's produce almost 9 bar of pressure inside the reactor.
Okay.
But with this system, we reduce not only the chemical, but also the pressure. We only operate at 4 bar maximum.
The power is the same.
Power
The
is
speed?
the speed is quite different because we can manipulate a lot. We can manipulate the tire size,
Mhm.
the gear ratio to produce higher velocity, but we choose to give high torque for the start.
So what is the maximum speed?
The maximum speed is almost half meter per second.
With this wheel.
With this wheel.
With the size of it. You
Yes.
have a bigger than that.
So you
Much
can
faster, right?
Yes.
Alright, very good design. And just to continue
Okay.
with the safety.
Okay, I just want to ask you about the safety factor. It's good one. You can define it, but I still curious about the insulation about those nozzle to that nozzle and to that reactor and vessel
Yeah.
to the vessel. How about the insulation? What do you use, and can you identify the risk if there is some potential hazard that maybe can be occurred during the operation,
Okay.
during the process?
Let me try to answer the question.
Yeah.
So there is several hazard
Yang lainnya
that
dong, yang lainnya.
Well, about the safety, right?
Yeah.
First, the water tank. Before the run, we always try to test the vessel, both
Okay.
of the vessel.
Mhm.
The simple one, we can test it below the water,
Okay.
right? So if there is bubble, then it's leaked, okay?
Okay.
So we always test it and like 3 times, 4 times, and then if there's no leak, then we can run the car.
Okay.
Okay. Then about the reactor, we have the safety bar, the vessel. We seal it both of vessel with rubber seal, right?
Okay.
Rubber seal.
Rubber
Then
seal. Okay.
the hose, we don't have any problem with the hose. It's certified. It's a certified hose which can maximum operation up to 10 bars. So when if the water moves to the turbine tank, the nozzle is safe. There will be no spill as far as we test on our experiment. The cap of the water, the turbine tank is fully sealed. Was it right here?
With the rubber.
Yes.
Also.
Yes.
Okay.
And then actually there will, if there is pressure come from outside from this tank, if the tank is vacuum, then it's quite dangerous. It will the water will spill. So we designed this turbine tank with a hole. We have
To reduce the vacuum of the.
Yes, exactly. Then to regulate the pressure as the water came in into the turbine tank.
Okay.
So we, as far as we experiment, that there is no spill or it's safe to operate.
Okay. We can
Okay.
continue.
So where you put the load then?
Oh, we put the load in the front of the car.
Okay.
Sure.
Show us. Can you show it?
In here. You put it on the center.
Did you check the balancing issue for each wheel? Because it seems like it will be heavier to the right.
Yeah.
With the
Saya
water.
miring.
You have the power, right?
We designed this car to move along straight. So if the this one and this one is so weight, and then if we put this off, it will be turn the car to the left.
Oh yeah.
So if we put the reactor in here,
for make it stable.
yeah, we make it straight along.
I'm curious about, don't you think there will be a fatigue issue because the water will continuously hit the turbine in relatively high torque? So what is the material of it? Because don't you think it will be cracked relatively easy? Yeah.
Is it strong enough
Oh, is it
for the high water pressure?
So actually, we have run this car so many times, right?
Yeah.
Then the material is accurate actually, but we make it more
Thicker.
to make it more thicker. We make it thicker. So and with that thickness, we can ensure that it's safe and it won't be broken.
But that will be in atmospheric condition, right?
Yes.
You don't use metal because you're afraid there will be a corrosion issue.
Corrosion issue, and of course weight is more.
Yeah, very good.
Maybe it's heavier
Maybe
than
also the
the
cost,
yes.
And the cost.
Or the cost of the
Yeah. And the last one is when your system running, the basic idea is only to give small amount of pressure, and the pressure will be transferred into the hydraulic, from pneumatic to hydraulic.
Yes.
So in terms of mechanical energy, you will lose several efficiency because of the several steps compared with the standard pneumatic.
Okay, so actually that's correct. But even there is loss, we also increase the energy in giving the momentum. Compared to air, like a momentum is because of the mass. For the same volume rate, the mass that hydraulic system give is much bigger than
Yeah.
pneumatic.
So what I mean, why don't you try the higher viscosity of liquid?
Okay, so
Jadi
Instead of
dicoba
water.
dengan liquid yang lain yang dengan viskositas. Kalau air kan mungkin sudah.
Okay, thank you Justice for the question. We consider water, we choose water, we see it from two aspects. First aspect is technical aspect, second aspect is economical aspect. First, from technical aspect, we choose water because let's compare it between water and oil. Oil is more viscous than water. If we use oil, the friction, there will be more friction between the fluid and the hose. So if there is a lot of friction between oil and hose, the energy will be decreased from the
I have to
economical.
remind you about the time. Thank you.
Okay.
Yes.
Yes.
Go,
Nggak
go.
apa-apa, tapi
I remind you.
Yeah,
From the economical aspect, we using water because we can get water anywhere, anytime. That's why we choose water to rotating the turbine.
Okay, the last one. I'm just curious. I just forgot. How about the scale kerak dari air? Bagaimana Anda mengatasinya untuk di dalam kontainer ini? Karena air yang kita gunakan pasti akan ada menimbulkan kerak, yang nanti akhirnya menimbulkan ada scale ya di sana.
Okay. In this design of the reactor, we use what is it? Nuts and.
Bagaimana to prevent the scale? Soalnya biasanya kalau boiler pun dia menggunakan air kan, boiler itu saja dia harus dipakai chemical untuk membersihkan.
Yes.
Karena bagaimana untuk menghandle masalah kerak? Karena bagaimanapun kita pakai air itu juga akan menimbulkan kerak. Ada skillnya.
Okay, we have run this car many times, and about the weeks we have checked the inside of the tank by putting this wing nut off and then open this vessel and clean the inside of it.
Manual?
Yes.
You use tap water or demineralized water?
Pakai air.
Oh, my hand.
Air itu air
Lapsa dengan tahu.
Just a tap water,
Tap water.
air keran aja.
Yes.
Tahu sendiri kan? Air keran.
Okay, last simple for the starting to run. How much water do you put there
1.1 liter
inside that
inside
water vessel?
inside this water vessel.
All right. Okay.
Okay, I think that's the last question. That's a lot of time. That was my presentation. Thank you very much.
Because as the former champion.
Well,
You did us a lot.
thank you very much one more time for the presentation. Now we may proceed to the discussion table right next to the registration table, and wish you a very best.
Good morning, honorable judges. Ladies and gentlemen, the purpose of chemical is for making renewable energy, right? So we can change the fossil fuel to the chemical, isn't right? Yes, but in fact, the chemical has very hazard that it can be dangerous for the environment. So it takes the selection of the right chemical in order to minimize the danger effect to the environment. So we design our car in such a way so can approach that following specification. And we give name our car as
Gatot Kaca.
the muscle of iron, the bone of steel. Okay, before we start or introduce our car, let's introduce our team. For the first, our team consists of me, Irwan Yufari Pratama, and then Alam Dewantara Jati, Tri Nur Aini, Khairul Habibi, and the last one, Rizky Alim Firdaus. Okay, we back to the tactile. The tactile, the muscle of iron. I mean, the muscle of this car based on the acrylic in the base on the car. So all the main material on the car based on acrylic. And the bone of steel, I mean, the bone of steel that is shaft that connected wheel, it is made from the brass. Okay, let me say our car. Actually, our car has four main parts. For the first, this is stopping. Stopping, we start stopping can hold reins rigidly. And this is box of energy. Box of energy covered by a lid. So there's no gas or liquid go outside. And this is load. Load has a Japanese team, and this is wire form for the team. And the last one, the electrical and all mechanical component placed on the bottom of our car to prevent spill, so can prevent also the short circuit.
So, this car is powered by electricity from redox reaction. We convert the electrical energy to be a mechanical energy using this motor. We are using aluminum as anode, hydrogen peroxide as cathode, and sodium hydroxide as electrolyte solution. So, we call that aluminum hydrogen peroxide battery. In this reaction, the oxidation reaction comes from aluminum with hydroxide ion, and then the reduction reaction comes from the hydrogen peroxide. Theoretically, from standard reduction potential itself can produce 3.21 volt. It's bigger than commercial battery. And then this battery is composed in 12 cells that combined in series. Itself consists one aluminum plate that covered by filter paper and one combination of stainless steel scrubber and cover. Now, from environmental aspect, to reduce the waste from the people, we use accumulator that doesn't work to powering motorcycle again, and the copper and stainless steel scrubber can be reused again, so we reduce the waste of our car. How about stopping mechanism?
Pelleter use commercial vinegar clog reaction. It's similar with iodine clog reaction, but we replace the sulfuric acid with commercial vinegar. The use of commercial vinegar is very beneficial in economic and safety aspect. Economically, commercial vinegar is cheaper than sulfuric acid, and then in the safety aspect, commercial vinegar is less hazardous than sulfuric acid. You know that sulfuric acid is a strong acid that very corrosive. And then, how about the stopping mechanism? The reaction happens in syringe. The LED sign through the syringe on the photoresistor, and then the photoresistor will work with the sudden drop in light intensity. The color of the liquid will turn from colorless to black, and then the photoresistor will detect it and stop the car. Here is the reaction. We use hydrogen peroxide and then sodium thiosulfate, potassium iodide, starch, and also vinegar. And in the safety aspect,
our team really concerned about safety aspects, including the selection of chemicals to be used. We used vinegar instead of sulfuric acid for the initial of stopping mechanism. The car is protected by the lid on the dorsal container to prevent the gas or the chemicals outside, and all of electrical circuit have been insulated to reduce the risk of short. There are some materials we need to build and to make Gatot Kaca well located. There are two parts of economical aspect. The first is fixed capital. The fixed capital As you can see that the total of fixed capital is 526,000 liters. And then the second part is operating cost. The operating cost based on how much we need to run this car to travel 20 meters, and the total of operating cost is around 1,000 liters. So we can conclude to make this car and to make this car well operated, we just need a cheap money. And then talk about the unit of our car. The unique features of Gatot Kaca are located on the selection of wheels and the materials. Gatot Kaca has 4 high-traction wheels which ensure the car will run without slip. Acrylic was selected as the material for the chassis due to its corrosion-resistant, light, and durable characteristic. The use of acrylic will reduce the total weight of the car, so it's easier to run. For pulses container, we utilize use accumulator container which is made from polypropylene. Polypropylene has an A score with excellence in terms of chemical resistance against aluminum hydroxide, sodium hydroxide, and hydrogen peroxide. In addition, the material that we use, namely copper and stainless steel scrubber, can be reused. This will reduce the amount of cost and waste generated. We also make the selection of the chemicals as best as possible about the hazard cost. All the materials that we use are not toxic and have less hazard as much as possible. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Let me see the time. Where was the time? Oh, 7 seconds. Just nice.
Just nice.
All right. Gatot Kaca. All right. From the Gajah Mada University. All right. So ideally, the ganja itself is not for the speed. Right. The ganja is not for the speed. And I'm sure also your car also is not meant for the speed. Yes. Right? That's why you name it Gatot Kaca. Right. So how about the question? I'll ask the question about how fast that your car can go with and without the load.
So, if we think about velocity of run, we have the gear in the bottom. It's 24 tooth, and it will be run in 40 centimeter per second. It's
That is the maximum.
No. In the optimum. In 5 until 15 minutes after we inject the energy, it's constant in 40 centimeter per second.
Okay. So the power or the speed will constant during the journey.
Yes.
All right. And did you try to optimize the power? Because this one you can manipulate so many variables. Right? Have you tried to optimize and make sure that you have a very a lot of power with the less of the consumption of your material or chemical? You try that.
We can optimize the velocity of our car, but in race we have to handle our velocity. If we got big velocity, the error or miss for the distance will be high. But if we got low velocity, we have small error.
But you need to show that you have a time frame that you need to satisfy. Right? So you need to go faster, set the target, you need to get faster over there and stop at the specific time here. So we don't want the car to work like a gajah. It's steady but very slow. That's why the speed also important over there. Right. So the rest we
Okay, Mr. Ari first. Oh, okay. I just want you to show me. Can you bring that car to me or more closer? Yeah. Okay. Why this design of this wheel different? Are you making different with this work calculation? Apa dasarnya Anda bikin desain yang berbeda antara dua wheel. Ya, peleknya beda desain.
Yes. I'll try to answer. Yes. For the wheel, this is different because in the behind wheel, there is shaft with the wheel is rotating, but in the
Front wheel, the forward wheel, what the front wheel with that design? Kenapa sih yang depan itu pakai desain seperti itu?
yes, from the front wheel there is shaft is fixed with the base. I mean the chassis, and that rotate that is just for this wheel. So the wheel there is half bearing in the wheel, half bearing. So the shaft not rotate, but the wheel is rotate. This in the behind wheel and shaft rotate, but in the front just wheel rotate. Because for the
Karena tenaga dorongnya dari yang belakang.
yes.
Oke. Kalau tenaga dorongnya dari yang belakang, saya melihat dari chemical yang Anda gunakan, memang cukup ramah lingkungan, ya, cukup ramah lingkungan. It's okay, you can answer in English or bahasa, it's okay. Tapi saya masih melihat bahwa Anda belum define. Jadi meskipun ini sudah ada NSCS, ada taruh di sini, tapi saya masih melihat masih belum ada yang harus ada define. Kalau bisa define nggak dari proses ini beroperasi pada saat dia dioperasikan, kira-kira ada bisa nggak ada identify potential hazard yang ada di sana? Silakan. Anda yang di pojokan, pakai kacamata, silakan.
Okay, I will try
Bisa
to
di-define nggak? Define itu tulis aja di situ.
I
Define.
will try to answer for the electrical circuit in this car.
Nggak usah electrical, semua hazard. What do you know about the potential hazard? It can be occur when this is operate.
Okay, for the potential hazard, saya mencoba bahasa Indonesia saja.
It's okay.
Jadi, saya akan menjelaskan bagaimana kemudian dari energi ini kemudian kita bisa menggunakan motor. Jadi dari energi ini kita tahu kita menggunakan aluminium dan tembaga sebagai.
Langsung saja Anda tulis. Potensial hazardnya apa saja? Ada list. Nah.
Oke, kita menggunakan kotak api bekas di mana dia mempunyai 6 sel di sini dan masing-masing kita isi dengan aluminium. Kemudian ada tembaga dan aluminium juga untuk menghubungkan antara sel. Nah, di situ kemudian dari lampanya kita isi dengan peroksida.
Please define and identify the hazard. Tolong identifikasikan dan mendefinisikan potensi bahaya yang bisa muncul karena Anda tahu di situ Anda menggunakan tapi kira-kira apa dari proses itu?
Jadi mungkin potensi bahaya karena kita injeksi peroksida dan larutan sabunnya, kemudian bahayanya mungkin di spillnya.
Spill, jadi ada potensi bahaya apa itu? Chemical berarti ya, bahan. Terus yang lainnya?
Oke, untuk elektrikalnya saya yakin bahwa ini tidak ada bahaya karena sel yang diproduksi di sini, itu kan kita produksi aliran DC, direct current, dan itu sama sekali tidak berbahaya. Jadi untuk electrical hazardnya insya Allah saya yakin ini aman.
Insya Allah ya. Tapi di sini ada tulis electrical shock.
Electrical shock itu bisa terjadi jika ini ada spill. Tapi kita sudah mengantisipasi, kita prevent spillnya. Jangan sampai kita dalam ruangan itu ada spill.
Itu jadi terjadi electrical shock itu pada saat loading.
Jadi pada saat kita menginjeksikan,
loading, injeksi itu.
Tapi kita mengantisipasi agar, karena kan elektrikalnya kita sudah tetapkan.
Coba bisa dibuka nggak? Kamu loadingnya dari mana? Oke, bisa tunjukkan ke saya? Jadi lihat ke sini.
Nih, jadi kita pertama loading ini.
Maju ke sini. Saya tidak menggigit.
Kita pertama loading ini di luar. Jadi kita tempatkan ini terpisah di mobil karena bagian elektrikalnya di bawah sini.
Oke.
I'm sorry, but I have to remind you about the time.
Okay.
Jadi setelah kita injeksi dan saya pastikan ini aman. Kemudian kita taruh di sini dan kita pasangkan. Kemudian baru aliran ini ke electrical circuit yang di bawah.
Coba bisa maju ke sini.
Is there any switch over there down there?
Yes, this is the switch.
Oh,
Okay, alright.
Oke, mungkin mengenai baiknya.
Ya.
Mungkin mungkin ketika ada cairan di sini nanti mengenai rangkaian airpressnya, jadi itu akan menimbulkan bahaya. Tapi sudah kita antisipasi dengan menaruh electrical komponennya itu di bawah. Kemudian yang kedua mungkin di bagian stoppingnya, di sini sudah kami antisipasi spillnya dengan menutup bagian depan dari stopnya ini. Jadi ketika dia bereaksi tidak akan ada tumpahan dari depan.
Kalau itu di bagian sebelah mana?
Ini kan tadinya kami masukkannya ini masih terbuka. Nah ketika dia terbuka dan gasnya berlangsung bisa jadi ada spill dari depan. Namun sudah kami antisipasi dengan menutupnya sehingga mengadakan ya tentunya sehingga tidak ada spill dan tidak menetes di sini sehingga tidak mengganggu dari electrical komponen yang di sini dan potensinya.
Pernah ada gelembung udara nggak?
Iya. Nah ketika reaksi berlangsung. Iya. Maka dari itu kami tutup sehingga tapi gelembung
Sampai seberapa level yang kamu isi?
hanya 2 mili. Jadi yaitu untuk safety-nya sudah kami antisipasi dengan menutup dari stoknya tersebut sehingga tidak spill dan tidak ada bahaya yang bisa ditimbulkan.
Tapi meskipun ada gelembung udara ya?
Iya, meskipun ada gelembung udara, tapi kan hanya sedikit dan memang kami desain mobil ini berjalan dengan waktu 3 menit. Jadi gelembung udara yang dihasilkan pun tidak sebanyak yang membuat dia spill gitu. Dengan tutup yang seperti itu.
Ya, istilahnya kalau saya pikir masih masuk angin. Kalau ada gelembung. Oke, silakan Kak.
Okay, just short question. I'm curious about the location of your photoresistor. What did you put it?
Nah, coba ditunjukkan.
Put the photoresistor in the electrical circuit in the bottom of the car.
So if there is a reflection from the floor, it will.
And this is the electrical circuit, and then I put the cable for the electrical circuit of photoresistor in this to this part.
Okay.
And we place the photoresistor inside this part.
Okay. So
it's
how
located.
about the ambient light? Will it
I think if we put this syringe in the
in between?
in between the photoresistor and LED, there is no light on the outside to.
Really? It will not change at all?
Yeah, I
Did
think
you
that
try
is-
indoor and outdoor as well?
Yes, because I am in several months into try and at night and at a day, and there is no error.
It's the same. Okay, good.
Good, all the best.
Okay, so very interesting presentation. Thank you one more time for Team Gatot Kaca. Now you can proceed to the welcome for Tim Kutara Janakaturi. You may take your car over here. For Tim Kutara Janakaturi, we'll have Dr. Muhammad Komarudin, Dr. Edwin, and Dr. Hari on the panel. And we'll have a sample rule that you have 7 minutes for presentation, 8 minutes for the question and answer session, and a total of 15 minutes of presentation session. The time will be shown on the screen, and you will have a whiteboard to accommodate. So then put out the name. Are we ready?
Yes.
Yes. On the panel, are we ready? Yep. Okay, so from Tim Kutara, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. All praise to Allah, the Almighty God, who has given us blessing and guidance so we can be ready to live in order to continue our activity. The honorable educators and all of the committees of the Geneva 2018. Let me introduce myself. My name is Muhammad Fauzan Rizki, and I am from Kutaraja Catholic. So Kutaraja Catholic is a camp equal team from Shakwala University. It consists of 6 members, which are Messi Adindra, Rahmi Sabitri, Taufik Inaldi, and Fauzan Rizki, Fikri Hamzah, and Fatur Rahman. So ladies and gentlemen, let me begin these presentations by giving you a little bit review about our CARS projects. This slide over here will also represent the outline or the point that we are going to elaborate in these presentations. Those are mechanical, power source, stopping mechanism, health and safety environment, and the last is economical aspect. From the mechanical aspects, as you can see, our car here is not only luxury in design, but also very cheap in cost. For the power source, we use a voltage cell principles, which produce a strong voltage and high current. And then for the stopping mechanism, we use an iron path reactions. And then from the health and safety environment, we read and implement all of the rules from material safety data sheets before making contact with chemical compound and others. And then for the economical aspect, the 4 prior aspects I told you are making a good combinations in order to decrease the money spent in finishing these cars. Okay, smooth. Yeah. So we know on the mechanical aspects. So this car is made of acrylates, which is very light in weight, but also strong enough to maintain a specified load. This car has a shoebox dimensions and 700 grams in weight, or and exactly 726 grams in weight. The speed that this car produces is about 0.6 up to 1 meter per second. The motor of these cars use DC motors whose rotations has been reduced by using gearbox. In order to forward the rotations from the DC motors to the shaft, we use 2 gears, and we have 2 fins made of acrylate, the first at the bottom and the second at the top, in order to prevent the electrical system between them. And then this car is designed to run safely by using the spurring system. The spurring system can be done by aligning the front wheels and the rear wheels at the same directions. Okay, now we move to the power source. Okay, we know on the power source. From the power source, we use a voltage cell principle in an accumulator systems which produce a strong voltage and high current. The electrolyte that we use in these cars are potassium hydroxide and the hydrochloric acids. The reaction, as you can see, this is the reactions. And then from the reactions, based on the reactions, we got nearly 2 volts in practical and 3.17 volts in theoretical. In order to make the reaction go faster, we add some potassium permanganate in the form of solid to the electrolyte. And the cathode of this reaction is copper plate, and the anode of this reaction is aluminum. So, as you can see, we can produce, by using this electrical system, all of the reactors can produce approximately 12 voltage, which we believe it can make this car run from the start line until the finish line, or even more.
Thank you. I would like to present about the starting mechanism. We are concerned about the raw material. We use also ionic flow reaction, but the ionic flow reaction have a three-step reaction. But in this reaction, we also concerned about the strategy to grade to target line. So we try to nagger with the increased vitamin C to get this chart. So this is an electrical circuit we use to conducting the ionic flow. What we use is control just like a photosensor. We're using Arduino Nano, one channel and one channel and like this. So for the next is about safety aspect. Safety aspect is very integrated in material safety data sheet and NFPA. So with like this, there are two material. Is about potassium hydroxide and hydrochloric acid. We decided replicate this one. So for handling, we use PPA for controlling and the time. Basically, we use goggles, respirator, hand glove, lab cloth, and safety shoes. The next, environmental aspect, Uttarajan Factory is equipped by integrated safety system, but it doesn't produce toxic gas. But in the reactor, it can be rinsed down by soap. So it's be clearly, and we hope and we believe it in environmental aspect is good enough. Last, in economical aspect. In the economical aspect, divided into four category. In our short, we just spend only 29 rupiah, 29,000 rupiah. In the mechanical, just 108 rupiah. So this is cheap, but it's still luxury. This is cheap in power short, but this is high voltage. So we believe this summary of the mechanical power source safety and further economic aspect. This is a good enough. From the mechanical, it's luxury, but it's keep strong. In the power source, this is material power source, but it can be easily handling in stopping, which you know. So the last say we can be say Uttarajan Factory. Salam. Thank you.
Thank you. Maybe the time.
12 seconds.
12 seconds. All right. Mungkin Ustaz, please.
Okay.
After
Okay, me down. I'm just wondering about, can you bring this to me?
Yeah.
Maybe closer. Okay, tell me, explain to me about the process, how can it from the switch on, and then why in behind wheel you close this with the hole and this not with the hole.
Oh, yeah.
Yes, yeah.
So basically, you know, the cover of the wheels is just to make this car more aesthetics.
Oh, just aesthetic factor.
So,
Okay.
will be no yeah,
Functional or some
just for
yeah, for if such a maybe can be reduce the speed or faster or okay. Okay, tell me the process when with this start, and then how come it's very how this velocity, how much speed can be occur the process.
As I told you before, the speed that this car will reach is about 0.6 up to 1 meter per second.
1 meter per second.
Yes, 1 meter per second.
Can you show me?
Yes. This
minus
0.0.
0.0. Okay.
So for the first, after making the solutions, we correct it to these cells, these cells, and then we make a solution for the stopping mechanism. And then after all of the solution is finished, we can start the car by using or by pressing this button.
Let's switch on. Okay.
Yeah, this is the button because if we don't use this, the reactions will occur directly when we put the solutions.
The reaction will be occur when you don't.
Yeah, when I put the solutions.
Even you not push the button.
Yeah.
Button just to move. No, the button is just to move
To move the mechanical aspects.
The reactions already occur, but to move the electrical potential reactions to the wheels, we press this button. And then after we press this button will works properly. And when the solutions become darker, the laser can penetrate the transparent button glass. And
the sensor is outside, right?
Outside, yeah. This is outside sensor.
This is a light sensor. Okay. How do you think about the effect of different ambient light? Would you try it?
Yeah, we have tried. From the electrical system, we have to make a program or check the data first before we raise this car.
You use a background light as your benchmark.
Yes.
Yes,
Is there any control to reduce the potential hazard? First, you must identify the hazard will be occur in all the process.
Oh,
when it operates.
When it operates. So the potential hazard, as you can see, we use potential permanent, which is a very strong oscillator.
No. If that operate, so that they move and untuk waktu jalan itu apa sih yang tahu bisa identifikasikan potensial hazard di sana? Selama proses reaksi di sini, terus dia jalan.
Just the potential hazard when we raise is not properly dangerous. It means it's not serious, but we just it's about the potassium permanganate we can use. This is how about the concentration? Just the concentration in the.
Kalau ini 3 loh potensial health-nya.
Ya
kan? Dari MSCS NFPA itu ada kelihatan itu potensial hazardnya untuk itu 3 tuh untuk health ya. Itu levelnya cukup tinggi. Nah, sedangkan bagaimana Anda mengendalikan supaya tidak terjadi seperti itu?
We can do it.
By decreasing the concentrations of the solution.
Decreasing.
First. Second, we can use this
If you decrease the concentration, then you will decrease the power.
Nah,
yes, exactly. We'll be decreasing power, but we can have the try to raise this car. Is immediately for in aspect all about the speed. We also connected to this data. So the potential our we can use is based on this data. So don't like to try and error now but this is that is the important data we need to how speed we can use and how to control the concentration of the system.
Oke. Pada konsentrasi berapa dia bisa optimal untuk bisa jalan konsentrasi?
Ya, dijawab
Iya,
silakan.
nggak apa-apa.
Kalau misalnya
Bahasa Aceh pun saya salah.
Terima kasih Bu. Makasih Bu pertanyaannya. Jadi kami sudah trial and error dengan konsentrasi yang bervariasi. Kalau di ICECC kan batasnya adalah 3 molar. Jadi kami mulai dari 3 molar turun molarnya. sampai kami mendapatkan di 1 molar itu kecepatannya udah 1 meter per second. Itu di 1 molar. So in the low concentration we have a strong voltage for this car.
Ya, jadi pada saat 1 molar ya.
1 molar.
Oke, mungkin akan lebih baik kalau itu dibikin tidak darker gini ya. Ini karena
Tidak.
ya nggak maksudnya secara estetika ataupun secara warna ini supaya kita bisa tahu levelnya.
We just try to make it here as a black.
Oh,
Jadi
oke. Silakan Pak.
How many times did we spend that? Do you think that the speed that you have is 1 meter per second, which basically contributed by the light or the heat, the light of your car? It's very light, it's less than 1 kilogram, right?
Yeah.
Is that will basically contribute to the speed?
It will be contributed.
That's why you operate it as a lower concentration.
Yeah.
Thank you, sir.
Yeah.
We have to trial and error with 1 kilogram. Yeah.
Yeah.
So that's this car can move if we add some.
If you have an extra load, it still can
Yeah,
move. It
yeah,
has lower
yeah, it
concentrations.
can move.
There is no effect to the rotations of the.
Okay. Yeah, about the, please be careful about your ambient light control.
Yeah.
For example, if suddenly there is a cloud covering
Yeah.
the sun outside, it will be affected relatively significant. So even though you already benchmarked it,
Yeah.
but during the race, suddenly you may have a fault experience. So please be careful about that. And what is the purpose of potassium hydroxide? You can use only hydrochloric acid. Why you need to use both of it? And don't you think it will form a salt, neutralizing
No.
from potassium chloride and water?
Yeah. So basically, we use 3 solutions here: the potassium hydroxide, the acid,
At the same time as electrolyte.
Yeah.
Yeah.
Yeah, but hydrochloric acid and sodium hydroxide will react.
Iya, itu akan bereaksi.
Yeah.
Nah itu bagaimana?
Yeah, I know the preferable reaction is like that.
Yeah.
But in the electrolyte, you put hydrochloric acid as well as potassium hydroxide in one mixture.
So we have potassium hydroxide to increase the oxidation because potassium hydroxide is a strong oxidation. So when we mix the hydrochloric acid with potassium hydroxide and we mix again with potassium hydroxide, that can make the high voltage.
Yeah, but salt formation will also be occur.
Maybe it's about the reaction, but how we can improve is firstly, in the first step, we have refining into solution, not obviously all the.
Yeah, but when you have all,
Yeah.
don't you think salt will occur?
Yeah.
Yeah.
Yeah, so you will have a lot of salt if you continue.
Yeah.
You know, yeah, I understand that.
Yeah, yeah.
If that salt occurs, so that's a problem. Big problem.
The salt, not like a crystal, but
I know.
Yeah, but this will reduce your electrolyte.
They will be reduce your electrolyte.
The conductivity of your electrolyte will
Will
reduce.
be reduced.
So that
Will be more lower because that salt it will be inhibitor
Yeah.
for that, right? Akan menjadi penghalang.
So based on the experimental experience from our past, we add just like 1.6 gram of potassium per nanogram. So if we increase the the potassium permanganate in the solutions, it will make the reactions goes faster. So the use of potassium hydroxide in this reaction is to stabilize the reactions. So it will go slower and it will stabilize the potassium permanganate in the reaction.
I apologize, but the time is over very much.
Okay.
I think it's enough for this discussion. I'm so sorry, but thank you one more time for Team Kota General for